The definite integral and area under a curve. The definite integral of the function f of x from a to b is the integral from a to b of f of x dx. This is equal to the limit of the sum of the areas of the rectangles. So the integral from a to b of f of x dx is the same as the limit as delta x tends to 0 of the sum of f of x times delta x. What we're talking about here, we've done some of this with rectangles before, is that we have rectangles like this. The widths here are the delta x and the heights are the f of x's. So the area of the rectangle is f of x delta x. The integral is the limit as the width of each rectangle tends to 0, and so we end up with an infinite sum of infinitely thin rectangles, if you like. And that is also equal to the limit as n tends to infinity of I equals 1 to n, the sum of f of xi delta xi. And in this case, n is tending to infinity because that's the number of rectangles. So in the first instance, we were looking at it as the rectangles becoming infinitely thin. And in the second instance, we were looking at it becoming an infinite number of rectangles. This is also known as the Riemann integral, which is something that you may see on syllabi. If f of x is greater than 0 for a, or x is between a and b, as shown in the diagram below, so the whole area is above the axis, then this definite integral is equal to the area under the curve. And you might have surmised that from the fact it was the sum of all these rectangles.